Hello, my name is Jeremiah House, and I'm doing a quantum tunneling experiment dealing with photons. So as you can see, there is a glass cup filled with water, filled about 3/4 of the way to the top. Now watch this. As I put my fingers behind, my fingers essentially disappear. Well, that is not the case. This is because the water and glass have a different reflective index than the air. So that air is acting as a gap, not allowing the photons to tunnel through the glass and the water back to the camera. So, if I put my fingers right here, they're on it, right? But you can barely tell where they are, right? If I start squeezing, they become more visible. And that is because I'm reducing that air gap, allowing the photons to travel back through the glass and the water, essentially tunneling through, right? So, as I get my fingers wet, and then I do the same thing, notice it takes a lot less force to do it. That is because the water is significantly reducing the amount of force needed to close that air gap. Now, just to show that it is not because my fingers are wet, I will be using this saran wrap. Okay? So this saran wrap, my fingers are on it. It is still pretty easy to see, right? That is because there is still water left on the cup. So, pretty easy. Pretty easy. Now, I do have different cups. We have this cup, essentially the same shape, but this time it has different pyramids on it, which does lead to the question, do different shaped cups affect quantum tunneling? So, same thing. I put my fingers behind, they're on now, right? Squeeze, then you can start to see it. Probably not as well, but you can still see it, right? We do the water, same thing. This time it is a lot easier to see, right? And then we will add the saran wrap. Boom. The water is still on there, and it's not just because my fingers are wet. It is because that water reduces the amount of air. Now, I have another cup. This one, shorter and more round, right? So, same thing. Fingers behind, you cannot see, right? And then if I squeeze, you can see it. But it is really hard to see. So, if I do get my fingers wet, like all the other ones, they do become easier to see, which is weird, right? You can, saran wrap, pretty hard to see, which does lead a lot to questions. Got one other cup. This one is bigger. It does have a smaller neck than the body itself, right? As represented by how close my fingers get. So I do the same thing. Put my fingers on, and then I squeeze. This time, you can only see the bottom one, right? You can't see the other ones that I'm using. So yes, the shape does affect quantum tunneling. So, water, then you can start seeing the top ones, right? You can start seeing the top ones. And I put them in the exact same spot, right? Okay. Add this. And look, it is easy to see. Now, I do have two other cups. They are quite big. They are bigger. So this will look a little scuffed real quick. Okay. So you got this, right? My fingers are dry. Put my fingers around. You can see them. Alright. Get my fingers a little wet. You can see them again. And then I use the saran wrap. And then you can see them, kind of. And then one more cup. This cup is very cylindrical. It's very round. It is much more like a circle. Not like a whole circle, but like half a circle. Put my fingers behind it. They disappear. Squeeze. You can see them, but not as well as you can see it on some other cups, right? Get them a little wet. Boom. You can see them easily. And then put some saran wrap on it. And notice, you can see the saran wrap already. Right there. Boom. So yes, this is pretty cool. And the answer to the question, is quantum tunneling affected by the shape of the object? Yes. Yes, it is. This has been Jeremiah House. Thank you for watching. Have a good day.